Let's evaluate the integral of inverse tangent of 1 over x. We're going to use integration by parts. And recall, integration by parts formula says that the integral of u dv is equal to u times v minus the integral of v du. We're going to call this integral our integral of u dv. The main problem is to select u and to select dv, but in this case it's quite clear what that should be. U should be inverse tangent of 1 over x, and the reason is if dv is equal to inverse tangent of 1 over x, then to go from dv to v we would have to integrate, but that's what we're trying to do in the first place. If we knew how to do it, then there would be no point to this problem. That leaves 1 dx for dv. The derivative of a u would be 1 divided by 1 plus whatever is inside inverse tangent, that's 1 over x squared, times the derivative of 1 over x, which is minus 1 over x squared in the numerator, and then times dx. And of course v, we're going to take v to be just x with coefficient constant equal to 0, coefficient of integration. Now let's simplify du. To simplify du, the best way to do it is to multiply the numerator and denominator by x squared. So in the numerator we have negative 1 over x squared times x squared. That would give us, this is what the original du is. Now multiplying it by x squared, we have minus 1 in the numerator, and denominator becomes x squared plus 1. So we're now ready to set up our integral. We have the integral of inverse tangent of 1 over x dx. That's the integral that we call the integral of u dv. That's equal to u times v, so that's x times inverse tangent of 1 over x, minus the integral of v du. But notice in the du we have a minus 1 over x squared plus 1, so that will make this a plus. V times du then would be x divided by x squared plus 1 dx. This is our integral v du. You can see it's a lot easier than the original integral. So the problem comes down to evaluating the integral on the right. That's very easily done by regular substitution. So x divided by 1 plus x squared. We're going to use variable w, let that equal to the denominator. dw is equal to 2x dx. 1/2 dw equals x dx. So the integral becomes 1/2 x dx is dw, and then we have 1 divided by w. So this is 1/2 natural log of absolute value of w, but w is x squared plus 1, so this is 1/2 ln 1 plus x squared without the absolute value, because 1 plus x squared is never 0. So let's finish this up. We have the integral, the inverse tan of 1 over x is equal to x times inverse tangent of 1 over x plus 1/2 natural log of 1 plus x squared plus constant of integration c. That's the answer.